I'll just record this. It's just going to be a long video. If you guys don't need to watch it back, but the other people can. Okay, so let's write a list. What things could you do if you got a data set like this and you're thinking open-ended maths? What could I possibly do? Shout out. What else could we do? What else could we do? Now, the awesome thing is you've learnt a few different types of regression lines this year. So you could plot that data and then choose what type of regression line you're going to put on there, whether it needs to be an exponential regression line, a logarithmic regression line, a parabolic regression line. But given that we're in a circular functions unit, it's going to be the sinusoidal, I don't even know how to spell that, regression line. All right, so then we can get the equation. Now we could do that on the calculator. How else could I possibly do it? We can do this by hand. We can make judgments and predictions and come up with our own equation by hand by looking at the data. We'll see how it plays out. I actually haven't double checked that data recently, so hopefully it's not awful. What other skills have we learned in this unit of work that we might potentially try and do with the data set? If we are in an investigation task, we're doing a SAC, so we're doing our assessment. What other possible skills would you want to try and show throughout that investigation? What other skills have we learnt about? So we've learnt about, so I'll just put a separate heading over here, other. We want to look for opportunities to do these things. So we're looking for opportunities to solve, graph, good. What else have we done in the unit? Probably about it, isn't it? So we did evaluating, we did converting, we did graphing, and we did solving. So what we've just created, this little brainstorm list, these are my quick start things that I could do. So this allows me to get started doing something. And on this side, these are the things that I'm going to look for opportunities to try and include as we work through it. Just going to find my lid, or my whiteboard marker will die. Okay, so let's actually start that. Which one do you want to do first? Plot it on the CAS. All right, break out your calculators. Does anyone not have a calculator? Two people? That is a great idea. I would do that. Anyone else? Only two? Three? Yours is in there? Oh, sweet. Do you want actually, is yours in there as well charging? Is yours flat or just forgot to bring it? Oh, sweet. You can borrow mine. And Logan, would you mind? Didn't you say it was in there and you put it on the charger? Okay, all right, I'll go grab one. Has yours got your name on it? We'll go grab it. Okay, can you enter? Yeah, come with me. I'm going to try not to talk too much because the microphone will keep working when I go in there. It could be weird. Just grab your calculator. Now, the first thing, I wouldn't use January, February, March, April, May, June, July. I would just go 1, 2, 3, 4, 5, 6, 7, 8. Make it numerical data because we're actually doing a scatter plot. All right? Great question. Really important that you should identify which you think is the independent variable and which you think is the dependent variable. Do you think it is more likely that what month it is will have an impact on how much rain we have, or how much rain we have will have an impact on what month it is? So the month is independent, x-axis, rain's dependent, y-axis. Oh, yep. Good. What else? Why didn't you drink it at recess? How come you didn't have it at recess though? During the break? Why didn't you have your drink and food during the break? Yes. This time. Yes, you can this time. Don't ask me next time. Okay? Question? Oh, your calculator is set in exact mode. So, home, 5 for settings, document settings, and see the one that says exact. So it's going to change everything to a fraction all of the time. You want it on auto. So basically, if it can give you a reasonable exact answer, it will. If it can't give you a reasonable exact answer, it'll give you an approximate one. And then do you remember how to get back to your document from there?
Card.
Press 4. Good.
How do I make a graph?
All right, so I'll show you again on the screen. So those people who don't remember how to get their graph, yep. So home, go to that purple one that looks like the graph screen. You with me, Tanisha? You missed the first part about where to click to get to there, didn't you? Press home. Go to the little purple graph screen, graph one down the bottom. Yep, and it looks like that. Yep, and then you want to click to add your independent variable. So in this case, we want the month to be the independent variable, and we want the rain to be the dependent variable. Okay, now I'm going to stop here because let's actually be mathematicians for a moment. Do you think that looks like a sine or a cosine graph? Why sine? Why cosine? Because it doesn't start at 0. Okay, good, right. So we've got one thing that doesn't start at 0. What else? When you do the sinusoidal regression line, it'll only ever do sine. All right? Your calculator will only ever do sine, because the difference between sine and cosine is just a horizontal translation. So we don't need both. It's handy to have both, we don't need both. But thinking like mathematicians, when you guys say that's sine or cos, you're kind of stuck a little bit in the space of, oh, we're doing a unit on circular functions, I'm only ever going to use sine or cosine. You could discuss, like if you were writing an investigation and you were talking about your understanding, you could say that this is possibly a quadratic graph, couldn't you? So you could try a quadratic regression line. You could discuss, yeah, you can do a quadratic regression line. Menu, analyze, regression. Oh, that was, I don't know what I clicked on there. Command Z, don't want to do that. So we could go quadratic. Menu, analyze, regression, sinusoidal. Yeah, excellent. So we're the point, like good points here. We tried a quadratic graph and we could talk about, we think the sinusoidal one is a better model. Why do you think sinusoidal is a better model?
It's more aligned with the graph.
Okay.
With less outliers than the quadratic.
Beautiful. So it's more aligned with the, it seems to be aligned with the points. There are less outliers. Outliers are points that are not on our line. Why else, and this is where we go to context, real life, maths, we want you to build in context. Think outside the points and the data. Why else do you think that a sinusoidal graph would be good to represent this data, Marshall?
It makes sense because it fluctuates with the different seasons.
Perfect. So it's about rain. And we know that rainfall is cyclic with the different seasons. And every year we go through a cycle. So you could argue that it makes sense to use a sinusoidal regression line because we're expecting rainfall to be cyclic with the seasons. That's the context. That is actually really important that you make those types of comments and link it back to what's going on in the background. I'm just going to delete this one while we're looking at it. A few calculator things here. Notice how I've got like all nice 2 decimal places. That's neat, isn't it? Who's got like miles of numbers that doesn't even fit on their screen? Anyone? One person? 2 people? Who's got like really weird, ugly fractions? You would have, Madeline, if we didn't just change that. So, good. Menu, settings. I've got this set to fix 2. Fix 2 is giving me 2 decimal places all of the time. If I go to float 3 is 3 significant figures. Have you guys ever learnt about significant figures versus decimal places? A couple of people saying yes. If you don't know, significant figures just counts the numbers, total number of numbers. Decimal places is how many numbers are after the decimal. So float is significant figures, fix is decimal places. Why might I choose to go to 2 decimal places? Often they ask to go for 2 decimal places, so it's just what I'm used to. Can anyone think of an argument for why you might do only 1 decimal place? There's probably a pretty good argument to use 1 decimal place. I'll give you a hint. Not. I'll give you a hint. Yeah. So you could actually say, I have selected to do 1 decimal place because the question was provided in 1 decimal place. This is already rainfall in millimetres. If you have 1/10 of a millimetre, you can actually visually tell the difference between 1/10 of a millimetre. 2 decimal places is 1/100th of a millimetre. You can't visually really tell the difference between 1/100th of a millimetre. So it's not really reasonable amount to think of the difference. And if you're talking about how much rainfall there is in a month, do I care if there's 1/100th of a millimetre difference? No. Probably not. Yeah? So I'd probably actually do 1 decimal place in this question, and I would say I chose 1 decimal place because the question was in 1 decimal place. These are things you can do to improve your score. You're justifying why you did it a particular way. All right? Okay. I'm talking a lot because I'm trying to actually help you and give you ideas for when you do your SAC. Sweet. Let's write down this equation. We've plotted it on CAS. We've done the regression line on the CAS. We've written our equation.
How do you do it by hand?
That is an excellent question. I'm glad you asked it. How could we possibly do this by hand? Can I come back to that?
Yeah.
This is exactly what I want to do next. But before I do, could I do anything from here with what I've got?
Solve for x.
What would you solve for? What are you like? When I'm solving,
X-intercepts.
I could find the x-axis intercepts. Are there any x-axis intercepts? So x-axis intercept when y equals 0, and then I can go 0 equals blah, 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 blah. No solutions. But if you got x-axis intercepts, You absolutely could do some solving to find the x-axis intercepts, couldn't you? Yeah?
The y is just
The y-intercept is when x equals 0. We've got a chance to evaluate here, don't we? We can actually substitute x equals 0 into our rule. Is it going to be an exact value? It's not one of those pi on 1 something that we know. So we can't do that by hand. We still have to type it into the calculator. But we've written this. We're showing a skill. All right? If we wanted to, we've got our equation, we've got the graph on our calculator. What could we possibly do to talk about graphing?
the dilations and translations.
We could absolutely discuss, I'll just say do on calculator. You could, so for graphing, we could discuss, this is an opportunity. So from the graph, it's an opportunity to talk about transformations. So we have, what do we have? What's this do? So we have a dilation from x by how much? Oh, no. The dilation. What's the dilation from x? Right. And that we can say is the amplitude. If you don't write this anywhere in your SAC, I don't know that you know it. If you look for opportunities to show me that you know these things, the question might not ask for it, but it is a chance to pick up marks. Investigation tasks are marked with a marking rubric, not a marking scheme. So it's not like you get 1 mark for each question or 2 marks or 3 marks. It's like there's 30 marks or 25 marks in the background on a rubric. You've got to get as many of them as you can. So you look for opportunities to show us the things that you know. All right? So dilation from x, that's the amplitude. Dilation from y. Now, it'll always be 1 divided by that, which equals 2. What does that change? The period. So we can then say the period equals 2 pi on n, which equals 2 pi on 2, which equals pi. I feel like that's wrong though.
Wait, so why is the dilation not just a half? What if it's from y?
Oh, hang on. 2 pi on, that was supposed to be a half. Which equals...
Yeah, if you don't divide it by 1, you divide that line above.
Oh, this one? Yeah, dilations from y are always 1 over. The reason it is because we need... you need half of the amount of what x was, or in this case you need 2 times the amount of x to get the same cycle pattern. Can I talk about that another time, because the numbers that we're using is a little bit messy at the moment. 4 pi. Does anyone want to take an opportunity to maybe link this back to our context? We've just found that the period... 2 cycles of the unit circle. How big is 4 pi? And what's 4 pi times 3.14? roughly. What's 4 times 3? Probably a little bit smaller. How does that relate to the context? Why would the period be about 12.5? Does that seem to make sense? There's 12 months in a year, isn't there? So the period being roughly 12 actually fits real life context. So this is an opportunity to say, this seems reasonable because I would expect a full cycle in 12 months. Right? So we're doing the maths. We're looking for opportunities to discuss it further and to show what we've learnt. And we're looking for opportunities to link it back to the context of the problem. Let me write that down. Maths, and then opportunities to show off, and then link to context. And you kind of want to do that on repeat. Have I answered the question? Have I found opportunities to show off what I know? Have I linked it back to the context? All right? I'm running out of space, and I know this is mad scribble. This is a little bit of where your brain should be kind of going in an investigation. It's not just do this question, then I do the next question, then I do the next question. I've got to try and think like a mathematician. All right, we'll come back to the doing it by hand. I'm not quite there yet. No, not necessarily. It'll actually, we'll talk it. It'll probably be pretty logical when you see that we've done it. Yeah, if you need to. All right, so let's keep talking about these dilations and translations and stuff for a moment. How far has our graph been translated? So what's that do to my graph? Up and down. What part of the graph did it move up and down? Moves the whole graph up and down, doesn't it? It's like the middle, isn't it? So the middle of the graph is at 61.5. What does that mean in our context of the problem? What's it about? Sorry, go back. What's the graph about? What's the topic? It's about the average millimetres of rain. So 61.5 is the middle. So what does that mean in the context of rainfall? It's the amount that we're going up and down around, isn't it? It's like the middle amount of rainfall. It is, what's a better word for the middle amount of rainfall? It's the average or the median rainfall level. So remember we had up here find the mean, median and mode. It would be really interesting to go back to the data, find the mean and the median and see if it is about 61.5. I'm going to bet you it's pretty close. All right? Don't do that right now, but that's a chance to show off. Oh, I found the mean of this data. I found that it was 61.3. That means this is a pretty good guess for the middle, of my data set. This is a reasonable suggestion. All right, chances to show off. Translations, while we're on translations. Now here we've got to be careful. It doesn't go 2.4 to the right. It's a sine graph. Sine starts at 0, 0, doesn't it? So it's actually starting here. It's at about 4.5, not 2.5. The reason for that is in my equation, here's my equation. It's on the video if you need to go back to it. In the equation, 26 sine, I have to take that half as a common factor.
Oh, do you have to times the whole thing by half?
So what would I multiply a half by to get 2.4? It would have to be a 4.8 there. All right. This is my n. This is my translation. That's a technicality. The calculator, the sinusoidal regression line doesn't do that for you. That would be a hand thing that you would have to add in there to get your translation. But the translation translates 4.8 units.
You have to do that whether it's a half, like for every.
If this was 0.546, you would have to divide that by 0.546.
What if it was 2?
If it was 2, you'd have to divide that by 2. So to get that out as a common factor, you just basically take whatever that is and divide it by the number you've taken out as a common factor.
How come we've never done that?
Probably because we've always had, and this is textbook versus real life, textbook they always set up the equations like that for you already. The same thing happens with quadratics. If it was 2x minus 3, that isn't a translation of 3 units to the right because this 2 is here. You do need to take out the 2 to get your translation. All right? So the same thing happens with the others. Why have you not done much of that before? Because it's probably actually considered a year 12 skill. Okay, 4.8 parallel to the x-axis. All right, what does it mean in context of the question? Let's think about why would the average temperature move across 4.8?
That's just probably how much the temperature fluctuates through the seasons.
I like that you talked about seasons. Let's talk about seasons then. If I was 4.8 months into the year, what month am I in? Sorry? January, February, March, April, May. 5 months is May. What season's May? It's like just, all right, okay. Do you know how no, I'm taking the piss now. It's autumn. Is it autumn or is it the start of winter? Still autumn. It's nearly winter. It's like in a transitional period, isn't it? So I would expect winter to be the wettest time. I'd expect summer to be the driest time. That sort of middle range would be about autumn, before it gets really wet in winter and before it's got, and after it starts to rain in the dry season. So you can link it back to context and you can talk about, it makes sense that this sort of average starting point is in the middle between our hot season and our wet season. Yeah? Linking it back to context will get you higher marks. All right. You want to take a breath? All right. I've done a lot of talking. What I want you to do for a moment now is, and I'll give you an equation. If we were going to do this by hand, I want to talk about how to do this by hand in the second period, And then we can come back to that homework task and we can talk about how we could have done that one by hand. So if I told you to get an equation that looks like this, how could you possibly work that out? I'm going to shut up. I want you to discuss in amongst the people that you've spoken to how you would possibly answer that. And the clues are actually in some of the stuff we've already done. We've talked about the period, we've talked about the amplitude, we've talked about the midline, and we've talked about the starting point. Cool? Discuss. What could you possibly do? Don't talk to me. Find a friend.
I'm asking as a double checker.
Okay.
Would you substitute in like values from the table?
Maybe. Sorry, I didn't realise it's till I had you locked out. Yeah, good point. What if I give you some hints? All right, I'll give you some hints. Didn't we say the amount it goes up is the midline or the average?
So it's not going to be 100% accurate
No, we're never going to hit every point.
when doing it by hand.
This one changes the amplitude, doesn't it? This one changes the period. What would we expect the period to be? What would you naturally expect the period to be? What's going on? We'd expect it to be 12. That doesn't look like a 12. How do I find out what n is if the period's 12? Start with those three things.
Work backwards with the equation.
Work backwards, right, cool. Could you have a go at that? If we know the period, okay, so try this. I'm trying to talk at you less and make you do some maths and think here. The period is 2 pi divided by n. You know that? Yep. And we want it to equal 12.
So it's over 1.
Can you solve this equation to find out what n is? Yeah? The midline's the average, isn't it? So could you find the average to work out where the midline is? And then would you use the average or would you use the median? I do that a lot, don't I, Mustafa? Is that you mocking me because I do this a lot? My year 10s pick on me for doing this a lot and talking with my hands a lot. Apparently I do it a lot. Okay, so 2 hints. 1, I want you to find the midline by working out the average of that data. Do you remember how to find the average? Good. I want you to try and find n by solving that equation. And then think about what the amplitude needs to be.
But so in like real, what we've just done, the n value was a half.
Yes?
The equation, but would that be a half? If we worked it out passively.
I don't know. What did Reese get?
Try to do these questions. I need to play one way.
Wait, are we doing poles?
That 0.8 needs to be in the brackets. But I love how I'm trying to give you hints about your SAC that's next week and you're choosing to ignore me. Okay. You want to ignore the here's a SAC preparation lesson and you want to ignore that, then yeah, sure, go. You look like you're lost. Do you need some help?
Are we meant
Yes. Could you please try and find out what n is by solving that 2 pi on n equals 12 equation? Or can you find out the average of those numbers because that'll be your midline? You can do it later. There's one up the front just to borrow mine for now.
With the period, how did you make
Oh, what are you solving for?
Trying to find the
What x is, so I need the comma x.
with the period? How did you make 4 pi approximate to 12.5?
Pi is 3.14,
Yeah.
so I just did 4 times 3.14
Oh, yeah.
is roughly 12 and a half.
It has something to do with 6. So with the term, it's pi over 6. And is that when you use your exact values table to say, well, therefore, if it's sine pi over 6 is 12.
All right, well, let's
But why are we doing cos?
yeah. Because that was what I had cos in that application task as the homework one. And I just wanted to mix it up a little bit and not give you exactly the same thing. No, it's still pi over 6.
Well, it doesn't matter.
So from here, I would multiply both sides by n. Then I would divide by 12. So this has nothing to do with sine or cosine. All right? So we've got that value.
But then linking it back to the equation we had before,
Yes.
that does equal.
Well, pi over 6 is actually pretty close to a half. Because 3.14 divided by 6 is just a little bit different from a half. So it's pretty close to what we had in the first one. We're not aiming to get exactly the same thing because we're doing it by hand now. Yeah. Yes. I would argue this is probably more likely the correct n value because we know that the seasons repeat every 12 months. This is probably more accurate, where our last one had that the period was 12.5. It said the seasons were going to repeat every 12 and a half months. We know that they're not changing that much.
Well, it's probably designed to be worked out like that.
Okay, did anyone find the average here? What did you get?
365.
So the average was 365. I feel like that's wrong.
I think you just added it up.
Did you add them all up? And divided by 12? Which was? 365. Oh, did you? Can someone check? Now, the reason, Tanisha, this is actually a really good learning opportunity because you're saying the average is 365. The average of these numbers can't be 365 because 365 is bigger than every single one of them. Yeah? So I know you've done something wrong. I'm just not sure what. Did you press equals before you divided?
It's 61.
Was it that one? Did you press equals before you divided? Is that what it was? Press the wrong button. Okay. Good. Okay. I've done lots of talking. I kind of had that bit of a break. A few of you have had a little brain down moment in a conversation. Let's try and bring it back now. If we find the average, that's our midline, that's the average rainfall for the year. We've just said that we've found that it's 61. Hang on, Jake, please. And we've got n is pi on 6. So we can actually start putting together our equation and say, well, maybe it's y. I still haven't thought about the amplitude, but it makes sense to have pi on 6 and then x minus something plus 61. We want the graph to move up 61 places, and we want the graph to repeat itself after 12. I can improve my answer by explaining why I did this and explaining how I did that. All right, and link it back to the context. If we're trying to find out our equation though, and we want to get the amplitude, how could I possibly maybe predict what I'm going to stick here? That's how far up and down it's got to go, right? Here's our data set.
With the maximum and minimum and find the range between them.
Yeah, so we could possibly find what's the maximum and the minimum. We need it to get up to what? 89.1. We needed to get down to what? 30. So what could our number possibly be here so that we're going to get to 89 and down to 30? Keeping in mind, we're going from where? So if I went from 61 and I went up 30, where would I get to? And if I went down 30, where would I get to? 31. So we've actually gone a little bit too high and maybe not quite high enough. What could I do instead? And this is where it's like, it's not an exact science. You have to be able to say what number you choose and justify why you chose it.
Could you use the maximum and minimum and find the difference between them and divide it by 2 or no?
Yeah, I like that. So you're saying I've got the maximum and the minimum. I'm going to divide it by 2 and I'm going to go from there. Yep.
29.
So 59.1, which means that's 29.5. The other thing that you can do is you can look at your graph and there used to be a way that I could add an equation to this. Tell me if you see something that says add a, might be in actions.
Plot function or no?
Yeah, where was plot function?
Analyze.
So analyze, plot function. So we can try plotting our function. We've so far got, we're thinking 29 cos pi over 6 x. We haven't gone left or right yet, so let's not put it in there. And plus 61.
It's just not shifted across.
Right. What do we think of the heights?
It's pretty good, pretty decent. It's a little bit off, but that's like just because of
So it was going a little bit too high and it was going not quite low enough. What could we change so that it doesn't... What could we change?
the A value.
We could actually change this one. That brought it a little bit lower, didn't it? So we started with the 61 because it was the average, and we adjusted it to put the graph on there.
It's still like it's going up too much and down too much as well.
All right. So this is where we're not going to get it perfect. You're playing around with it and you're justifying the decisions that you make. Do you need to make a quick note on how to do that plot function on the graph there? So menu, analyze, plot function. Allows you to draw another rule onto your data set so you can try and see if it fits. Okay, last thing, we have to choose to move this left or right. So we're going to end up adding something in this equation to get it to go left or right.
Would you look at the two where it's peaking, just like kind of be like what's the gap between that,
Yep.
and then you would just shift accordingly?
So I would literally just I could be clever and say, well, it's a cosine graph, so I want the peak to be when? I want the peak to be, no, going back to context. When do I want the peak to be? Middle of the year, which is winter. What's the middle of the year? How many months? Jake? I need it to go 6 months. So we can actually go, let's just start with saying I started with moving it 6 places to the right because I wanted the peak to be the middle of winter. Well, what do we discover? The peak rainfall is perhaps not in the middle of winter. When's the middle of winter? Middle of winter is not actually June, it is the 7th month. And then we're kind of going, oh, maybe I want to tweak it a little bit more. But here, this is your opportunity to talk about context. All right? If July is the middle of winter, then the middle of July would probably be the middle of the peak rainy season, wouldn't it? So the middle of July, if July is 7, the middle of July is 7.5. And you can then make a comment to justify why you chose that number. And you can draw it on your calculator to show how it worked. And then you can copy what you had on your calculator onto a piece of paper to show me what you did. All of those things. All right? So I'm pretty much done what I wanted to do now, but I want to go back. Maths, opportunity to show off, linked to context. One of the things that you can do in your investigation task is watch the time and think, have I got more time to show off? Have I got more time to write a comment about why I did it a certain way? And add those extra bits. If you're sitting there going, I don't know what to do, you're maybe not using your time as well as you can. Because you can just be using your calculator and trial and error to try and make things work as well. And then sort of like reverse engineer it. Just come up, 7.5. 7.5 looks really good. That was just a lucky guess. But now I'm going to tell Mr. Boot that I chose 7.5 because it's the middle of July. And it sounds like you did it on purpose, but it's just like a really nice talking point. Cool? All right. I'm going to stop the video. What I want to do is go back to 2 things. One, I would like you to finish this task if you didn't do it for homework and ask me questions. Oh, yes, it is me. That's annoying. Let's not put that password in. That's the wrong one. You must think I'm really stupid. This is the task that I gave you last time. I'll just zoom in for a moment. Notice, justify your reasoning. They want you to talk about why in the context of the problem. Justify your reasoning. Notice we did a sinusoidal regression and then we found what the graph was in terms of cos by hand. Exactly what we just did. All right, exactly what we just did. Discuss how you determine the values of A, B, C, and D. So this links as a practice modelling task for your investigation. This is a practice investigation. That's why I gave it to you. I wanted you to do it at home because then you could kind of be a little bit on the front foot when you were thinking about what we were doing today. And then you're going to have Monday to do revision and practice, finish off those questions, make sure your summary journal's good. and on Wednesday you're going to go into the investigation task. Yeah? I feel like I've lined up the dots pretty well to help you. Is there anything else you want from me at the moment? Post that video, yeah. I can't do it till I'm at home because school internet doesn't let me.